Welcome to Python Basics with EJD. Having taught data analysis, data science, and things like that, I mean, even scientific computing, SQL with Python and everything, I discovered that it's necessary for me to actually have a playlist that deals with the fundamental, the essentials of Python in such a way, in a very comprehensive manner, such that it's to serve as a basis for anybody who wants to do anything with Python. So if you want to do anything with Python, like you want to do data science, data analysis, machine learning, scientific computing, web design, or whatever you want to do with Python, so this playlist will be that first course that you need to take to understand what Python is really about. And once that is out of place, then you can then move on to whatever you want to do. Of course, if you have been following me, you would discover that Python, it's all about what you want to do and the libraries that are necessary to do that. I keep talking about the fact that if you want to do, say, scientific computing, you need things like, you need libraries, Python libraries like SciPy, NumPy, and SymPy. All right. If you want to do data analysis, basically you need NumPy and Pandas. Of course, for data visualization, then go ahead and talk about Matplotlib, Seaborn, Altair, Plot9, and all those. Then, of course, for machine learning, then you begin to talk about Keras, TensorFlow, and there's another one that I'm not remembering right now. Keras, TensorFlow, PyTorch, and so on and so forth. All right, so it all basically depends on whatever you want to do and the libraries you need for that. So this first video will be an introduction to Python. And interestingly, what I've been doing all along, I've been using Jupyter Notebook for Python, and I use it as the integrated development environment IDE. And of course, there are so many of that. You can have Jupyter Notebook, you can have Spider, you can have VS Code. There is IDLE and so many PyCharm and so on and so forth. But this time around, looking at the trouble some people have to go through before they to install Python through to install Jupyter Notebook via Anaconda, I just discovered there's no point wasting time with that when you can easily use Google Colab. Basically, Google Colab is based on Python. So Google Colab, and what all you need for Google Colab is your email address. Once you have a Gmail address, then you can always have access to Google Colab. And it's everything, it's almost everything like what you have in Python. So I mean in Jupyter Notebook. And that's why my focus in this particular playlist for Python basics, we are going to be using Google Colab as our integrated development environment, which is built on Python, Jupyter Notebook, by the way. Okay, so let's go for it. Introduction to Python. And just since I told you I will be using Google Colab, all just going to do is I'll go straight. And to go for Google Colab, just come to this place, to your search bar, and just type Google Colab in, and it brings Google Colab. Then you just click on it, and it takes you there. So my very first lesson is introduction to Python, right? So I just click on that, and it opens that page for me. Okay, of course, the next video is going to be about how to navigate, how to move around with when you talk about Google Colab. So how to navigate, how to move around. When I dealt with scientific computing with Python, the second video was about how to explore Jupyter Notebook. So the second video for this particular course on Python, this particular playlist on Python basics, is going to be on how to explore Google Colab. So get ready for a very nice time. I also remember that when I did scientific computing, I didn't pay attention to the fact that my videos can be what I am showing you, the codes I'm showing you may not be that visible, So this time around, I've discovered I can actually expand to make things a bit more legible, right? So you're going to see things a bit more clearly than ever before. All right. So since we're talking about introduction to Python, so we need to understand what exactly Python is, right? What is Python? So uh, you need to understand that Python is a high-level programming language that is widely used in a variety of fields, including data science, web development, scientific computing, machine learning, and so on and so forth, even natural language processing and the rest of them like that. So that is what Python is. It's a high-level programming language. Now, the question is, what is a high-level programming language? So, of course, to contrast high-level programming language, you have low-level programming language. Now, low-level programming languages are known to be close to machine language. They can interact easily with your machine, with your computer, with whatever is running the computer in the background. But the trouble with low-level language is that they can be quite difficult to write. The code can be quite difficult to write and things like that. But high-level languages are very close to human language. So you see, there's machine language on one side, there's human language on another side. So low-level languages are close to machine language, but they are difficult to decode, while high-level languages are close to human language. So, and Python is one of such. So that's why Python is one of the easiest programming languages to learn like that. So you can, it's more like most of the times using Python is like you're speaking English basically, So that's why it's a high level programming language. So of course the benefits of low level languages, a low level language is that it is very fast, For instance, a language like C sharp, C++ will be faster than Python because those ones are low level programming languages because they are close to machine language. But Python may be slow to execute on the same kind of data, on the same kind of project or something, But of course, somehow the researchers keep going on to find a way of blending the two together, of to say using Python, for instance, as your front end, and then you now use all those low-level languages as your back end. So as a human being, you can easily write codes in Python, but then you have something that converts it to low-level language to make it the processing fast. So there are a whole thing going on in that regard to make sure we have the best of both worlds. Okay, so that's the idea of high-level programming language. So Python was first created in 1991 by Guido van Rossum. That sounds like a Dutch name. I want to believe it's Dutch, and has since become one of the most popular programming languages in the world. In fact, it is the #1 language for machine learning. Right. So, of course, when you come to statistics and statistical analysis and things like that, you begin to have this rivalry between Python and R. But somehow, Python is my preferred one because I'm more inclined towards data science, machine learning like that. So what are the features of Python? So #1, it has readability and ease of use is very attractive. So the syntax is simple and straightforward, making it easy for beginners to learn and understand. It also has a large standard library, which includes a wide range of built-in functions and modules that can be used to perform a variety of tasks from working with data and files to networking and web development. Now, I told you already that whatever Python is, you need, so if you want to learn Python, you need to know what exactly you want to use it for. For me, I use Python for scientific computing, and as a result of that, I need libraries like SciPy, NumPy, and SymPy. Then I use it for data analysis. So there I need NumPy, pandas, I need data visualization libraries like Matplotlib, Seaborn, Plotly, Plot9, and so on and so forth. Then, of course, if you want to use it for machine learning, you have Keras, PyTorch, TensorFlow, and so on. Then, of course, for those who want to use it for web development, then you can be talking about Flask, Django, and so on. So many libraries. So it depends on what exactly you want to use it for. Then, of course, that ties up with the idea of high versatility and wide range of applications, which I just mentioned not quite long. So in data science, it is used extensively for tasks such as data cleaning, data analysis, and machine learning. So for data cleaning and data analysis, there you talk about NumPy and Pandas. For machine learning, of course, I've mentioned Keras, TensorFlow, and PyTorch. So in web development is used for building web applications and APIs. So web development, you need Django, Flask, and some other ones. It is also used in scientific computing and simulation and is a popular choice for scripting and automation tasks. Okay, so it has a high versatility and wide range of applications. Then we'll talk about a strong community support, right? So there are a large number of third-party packages and libraries available which can be used to extend the functionality of Python and make it even more powerful. For instance, I can get to that point where I understand this so much that I can actually, make my own libraries for some specific use cases like that, So that kind of support makes Python really attractive. Okay. Now, Additionally, there are many online resources, tutorials, and forums available for learning and troubleshooting Python. So if you go to X, former Twitter, or you go to LinkedIn, Facebook, and all those places, you can find pages where they actually teach Python, give snippets on Python, and all of that. So that makes that the support for Python is really, really massive. Now, let's go to Python programming modes. So there are some programming modes. There are basically two of them, right? They are interactive and script mode, for instance. So for the interactive mode now, when you use something like Jupyter Notebook and Google Colab, you're working basically in the interactive mode. So the interactive mode refers to working with Python interpreter directly, typing code into the command line and getting immediate feedback. For instance, I could just, even right here, I could just create a, we are going to be navigating Google Colab in the next video, so never mind. So I could just go straight and say, oh, X is equal to 2, Y is equal to 5, and then I just come here and say print X plus Y, right? Just say print X plus Y, and then I just run it, and it gives us, you see this rotating, so it just runs, and then it gives us an answer easy, like basically, so you have 7. Okay, so that's interactive. So I save the results immediately. So interactive mode refers to working with the Python interpreter directly typing code into the command line and getting immediate feedback, just like we did here. This is a great way to experiment with code and try out new ideas, as you can quickly see the results of your code as you type it. Interactive mode is also useful for testing and debugging code, as you can easily experiment with different inputs and see how the code responds. So, I can try out several things. As we go on this journey, you're going to see a whole lot of this. So that's the interactive mode. How about the script mode? The script mode refers to writing code in a separate file, typically with a .py extension. Interestingly, when I'm done with Google Colab, I can actually download as an IPYNB, which is just like whatever you get in Jupyter Notebook. And then you can also download that in .py notebook, which you can now run in VS Code or in Spider, PyCharm, and all of those places for sure. Okay. So that's the thing about that. All right. So we go back to what we're talking about. Interactive mode versus, okay, yeah, we're still talking about the interactive mode. So it refers to writing code in a separate file, typically with a .py extension, and then executing that file using the Python interpreter. This is useful for more complex programs that require multiple lines of code or that need to be run multiple times with different inputs. Script mode allows you to write and test code in a separate environment and then execute it as needed. Of course, if you want to think about use cases, right? For someone like me who is always teaching these things, interactive mode is always good for me. Like that's why I like to use Jupyter Notebook and now Google Colab. But for script mode, maybe as a software engineer, you don't have time to keep testing every line of code you write. So you may need to write like 1,000 line of code before you now try it out, and then you think of debugging. So in that case, you need the script mode to work for you. So it is useful for more complex programs that require multiple lines of code or that need to be run multiple times with different inputs. Script mode allows you to write and test your code in a separate environment and then execute it as needed. When running a script, you can do so in a number of ways. One option is to run the script from the command line using the Python command followed by the name of the script file. For example, if your script is called my_script.py, you would run it using the command Python my_script.py. Another option is to use an integrated development environment like IDE, like PyCharm, IDLE, Visual Studio Code, or Spider, which allows you to write, test, and run your code for all all in one environment. Okay. I mean, you can already start getting used to this now. Like I can actually bring this down and make it into a new bullet of its own, right? So those are the kind of things you'll be learning when we get to the next video, the second video, because so that I've split that out now. So you can use an integrated development environment ID like PyCharm, ideally Visual Studio Code, or Spider, which allows you to write, test, and run your code all in one environment. Now, what's the comparison behind interactive mode versus script mode. Like I've given you an example already that if you want to, as a teacher, I need to explain the code line by line. So interactive mode works better for me. But as a software engineer, you may need to write several lines of code before you even try running or debugging. Then in that case, script mode works better. So both interactive mode and script mode have their advantages and disadvantages. And which one you use will depend on your specific needs and preferences. So interactive mode is great for quickly testing code and getting immediate feedback, while script mode is better suited for more complex programs that need to be run multiple times or that require multiple lines of code. So now that I'm zeroing in on Google Colab as opposed to Jupyter Notebooks that I've always used, well, they are more or less about the same because Google Colab is even built on Jupyter Notebook, as you're going to find out. Google Colab is a cloud-based platform provided by Google for running Jupyter Notebooks. So it means you can write something in Jupyter Notebook and upload it in Google Colab and then have it work like that. Maybe I'll give an example in the next video. So it allows users to write and execute Python code in a web browser. As you can see, so this basically in a web browser, right? Eliminating the need for local installations and configuration. So for Jupyter Notebook, you needed to maybe go through Anaconda and install Jupyter Notebook and everything. With Google Colab, it's totally not necessary, right? Colab provides a free GPU and TPU, that's tensor processing unit, runtime environment, enabling users to take advantage of accelerated hardware for machine learning tasks. It also integrates with Google Drive, allowing easy access to files and collaboration features. So your storage is taken care of in the cloud. You don't have to worry about saving on your device like you do with Jupyter Notebook. So you can, so anything I write in Google Colab is automatically stored on Google Drive. So that's one big advantage of Google Colab. Or if you have very large data sets and maybe you cannot hold it on your computer, you can easily upload it on Google Drive and then call it in Google Colab. So that's one beautiful thing. To use Google Colab, just like what I showed you just now, you can just search for Google Colab and it brings this for you and you just click. Or you can navigate to this link, collab.research.google.com, and sign in with your Google account. So once you have a Gmail account, you're good to go for Google Colab. So once you're logged in, you can create a new notebook or open an existing one. The Colab interface is similar to Jupyter Notebook with code cells, text cells, and various toolbar options, right? In Jupyter Notebook, we have markup. That's what is called text cell in Google Colab. We also had code cells, which is also code cell here. And then we also have the option of raw, like just write the code just the way it is, like that. So Colab provides a runtime environment where you can write and execute Python code. It also supports markdown cells for adding formatted text, images, and links to your notebook. You can install additional libraries, access files from your Google Drive, and even leverage GPUs and TPUs for computation by changing the runtime type. Now you can automatically even just store whatever you do on Google Colab. You can take it straight to GitHub, which is a repository of sort for whatever code you're writing. Okay, so to execute code in a Google Colab notebook, you can click on the code cell and press the play button or use the keyboard shortcut Shift plus Enter. All right. So the code will be executed and the output along with any errors or print statements will be displayed below the cell. So as you can see what we have here, right? So when you come to this cell, you can see the play button. So it is when you click the play button that you get this result that we have right here. Okay. Then of course you could also come and use Control Enter, hold down Control and press Enter, it runs. Then if you want to, after running that cell, you want another cell to automatically be created, you can use alternate enter. All right, alternate enter runs that code and then it opens a new cell for you. So those are the kind of things you need to know about Google Colab. So we are going to explore all of that in the second video, in the next video after this for sure. Okay, so the code will be executed and the output along with any errors or print statements will be displayed below the cell. So here when we run this now, a result was printed. That is, the result is 7. We are going to learn about printing and all of these things as we progress in this playlist, right? So Colab notebooks can be saved to your Google Drive or downloaded as IPython. So you can download it as IPython, which is more or less like what you even get from Jupyter Notebook normally. So you can save it's automatically saved on Google Drive. Then you can go ahead and download as IPython, just like I showed you before. You can also share your notebooks with others for collaboration or publishing purposes. Overall, Google Colab is a convenient and powerful platform for working with Jupyter Notebooks in the cloud, especially for machine learning and data analysis tasks. So that is our introduction to Python, especially focusing on Google Colab as our integrated development environment. So thank you so much for listening. Let me know how helpful this video is for you. And if there's something you'd like me to try out in the course of this playlist, feel free to let me know in the comment section, either on Facebook or on YouTube, right? If you have not subscribed to this channel already, you'll be missing a whole lot. So go ahead, click on subscribe and also hit on the notification bell so you can always get alerted each time a new video is released. You can also become a member of the channel by clicking on join, and then you see some levels of membership with some special privileges attached. Ultimately, don't forget to like, share, and comment so that more people can have access to this great content I have going on here. Till I come your way again, keep doing Python right, should I say so? Bye.